All right, let's go ahead and get started. Any questions before we get back into anything? I think the web work for the last section we just finished was due. I don't know. I don't remember what the original date was, but I pushed it to Sunday. Tomorrow. Okay. So it's now due on Sunday. If you haven't already looked at it, please do so. We spent 3 days on that in here. I don't know if there's another section where I expect to spend 3 whole days on it. It's a tough section of material. Please start looking at it now. Just a reminder, since it's my first day, I will have office hours this afternoon from 1:30 to 2:30. So if you want to talk about that, please come see me. But yeah, it definitely deserves more time than what I originally guessed. So moving on to something new today. Integration of partial fractions. So to kind of warm up to that, again, like so much of what we do at least has relationships to things you've already done. So that's what I want to start with. Can we add these two things together? Can we add these two fractions together so that basically I'm writing them as a single fraction? How do I start that process? Least common denominator. In this case, what is the least common denominator? Do they have anything in common? Right. So they have a 9 in common, but the other factors, the x plus 4 and 2x minus 1, kind of subtle. It seems like they do have that x in common, but basically what we want to ask is this: is there something I can multiply x plus 4 by to get 2x minus 1? And the answer to that is no. So because of that, I have to basically, those things are like primed to each other. Like neither one contains factors of the other. So because of that, my least common denominator is going to contain both of them multiplied by each other. So basically, here's my common denominator. I'll duplicate this for now. Because what do we have to do now that we know the common denominator? What do we have to do next? Okay. So what do I multiply this? So what's this left fraction going to be? 4 times 2x minus 1, because that was the factor that was missing. And over here? Yeah, so then x, so there was a 1 there. So 1 times x plus 4. But now they have a common denominator, right? What does that common denominator allow me to do from here? Okay, I can combine. How's the combination going to look? Or what should I do to? Okay, so so let's expand those. So 8x minus 4 plus x plus 4 over 9 times x plus 4 times 2x minus 1. So what happens here? So these cancel, then I get 9x over 9. So all told, I get x over x plus 4 times 2x minus 1. So maybe not something you've done all that recently, but probably is something you've done, right? So any questions on how to go that direction? So basically, I give you multiple fractions and you combine them into one. So basically, what we're building up to now is how to reverse that process. What if I give you something? I already got a mistake. What if I give you something that is complicated and condensed into only one fraction? Is there any way I can pull this apart? So that's what we're going to talk about now, because I want to integrate this thing here, but it's hard to do that. There's a lot of stuff going on. It's hard to do that, but if we can pull those apart and deal with, instead of one complicated integral, many smaller ones, that's a good place to be. So basically what I want to do is this. I want to break this fraction down into smaller fractions. So what I want to think about is this. What kind of fractions, basically, okay, how do I want to ask this? The first thing we had to do here was what? Find that least common denominator, right? So here, let's think about this. Basically, that x plus 4 and x plus 4 times 2x minus 1, that is the least common denominator. So what kinds of things might I have added together to get that least common denominator? Like what would the more basic looking fractions look like? Or specifically, what denominators might they have had? X plus 4 and 2x minus 1. I have no idea what the numerators were, so I'm just going to call them A and B. So you're probably not going to be surprised by what the A and the B are, because this is the same one we just did the other direction, but I want to show you the process on something familiar. So are we good with the rationale so far? Basically, how we split the fraction I gave you up into these two littler ones. All right. Basically, our goal here now is to figure out what these A and B, what these unknowns are. So what I'm going to do from here, actually, does anybody have any idea where I would go from here? Has anyone seen this? Sort of. I see hands partly raised. Multiply A times 2x minus 1. So basically, you want to multiply this first term only by, so basically,
just A.
Okay.
If I don't remember.
Okay. So you're on the right track. One thing I'll point out is you can't, basically, if you're going to multiply, you got to multiply everything by the same thing, right? But let me ask you this. Why do you want to multiply this first term by 2x minus 1? Okay. What about this what would make this easier to look at? There's something going on here that probably all of you are not excited about dealing with. Let's try clearing the fractions. How could I get rid of all the fractions here? So, I mean, I could FOIL this out, but it's still going to be a denominator, right? How would that look?
Like x times x plus 4 to the negative 1.
Oh, okay. So yeah, that would clear the fractions, but basically what I'm saying is there's a way to basically only be dealing with purely linear things. So what I'm going to do is this. I'm going to multiply both sides by what our common denominator is. So multiply left-hand side by x minus 4, 2x minus 1. Thank you. And if I do that, what happens to the left-hand side? I don't even think I have the 2x minus 1 on the left, right? So on the left-hand side of the equal sign. That should just be x, right? And what about this term, this a term? That'll be a times 2x minus 1, which I think is what you were expecting to see. Plus b times x plus 4. So it made our equation a little bit easier to deal with. So the goal is still the same. I want to figure out what those unknown constants a and b are. Any ideas on how to go from there? So let's distribute and see what happens there. So I get x equals 2ax minus a plus bx plus 4b. And one more thing I'll do here, I'm going to factor things out. So basically, I'm going to group these terms in two ways. Some of these terms have an x multiplied by them. Some of them don't. So I'm going to group them that way. So the terms that have an x are the 2a, x, and the b. And what else is there? So basically I've grouped my terms up by which ones have that variable x and which ones are just constants. So knowing that left-hand side and that right-hand side have to be equal, can I say anything about 2a plus b? Or can I say anything about negative a plus 4b? What's the coefficient of x on the left-hand side of this equal sign? 1, right? So what does the coefficient of x have to be on the right-hand side? Also 1, right? So because of that, I'm going to say this is true. I don't know what a and b are, but I know that 2a plus b has to be 1. What's the constant on the left-hand side of the equal sign? On the left-hand side? Yeah, it's 0, right? There is no constant. So basically, it's essentially x plus 0, right? So if the constant on the left-hand side of the equal sign is 0, then the constant on the right-hand side has to equal 0, right? So that means negative a plus 4b has to equal 0. So I want to stop there because this is an important idea to conceive of. Are we okay with how I wrote this system of equations on the right? Okay, if we're okay with how we got these equations, are we able to solve that? Can I do I have enough information to find out what a and b are? Question?
Yeah, is it always going to end up, like, I guess that's simple?
And you might have higher powers of x, you have to deal with more equations and more unknowns. But the core idea here is true. Basically, this equal sign is very powerful. This very simple thing, or this very simple looking thing, has to equal this much more complicated. So because of that, the only way they can be equal is if every single power of x, all those coefficients agree on either side. So in this case, we only have 2 powers of x, 0 power and power of 1. So that always holds true. I just might have more things to worry about. Anything else? All right, so how do I, from this system of equations, how do I solve for a and b? What's that? One's equal to 0.
You would solve for, like, say you're solving for b, so then b would be 1 minus 2a, and then you plug in b into the next.
So yeah, you've probably heard things like substitution, elimination, but there are probably multiple ways that you've solved equations like this in the past. Let's go with that substitution. If I do b equals 1 minus 2a, and then what do I do with that b equals 1 minus 2a now? That means that the other equation could be rewritten like negative a plus 4 times 1 minus 2a equals 0. So negative a plus 4 minus 8a equals 0. I'm going to save space by, so what does that mean that a equals? 4 over 9. So this right here, well, yeah, let's go ahead and rewrite 4 over 9. Can I get b from there now? B is exactly 1/4 of that, so that should be 1/9. So basically, the a and b that I got just now, is that consistent with what we got or where we started that last slide? I think it looked a little different, but basically, yeah. So we haven't even done the integral part yet. But any questions on how we got to this step? Go ahead.
Really quickly, just so I'm writing it, is it okay to put the 4/9 over x plus 4, or would you have to do 4/9 times x plus 4?
Depends on what you mean by okay. Like, I know it's not like great practice, but in terms of like the whole goal here is to do an integral. Mm-hmm. I think it's probably easier to think about the integral if we do it in this kind of clumsy looking way. So basically, I might have a problem if we were going to leave it like that, but we actually have something else to do. Okay. So let me, maybe after we look at the integral, it might be more clear why I want to leave this as just 4/9. So now I have these two integrals. The integral of 4/9 over x plus 4 plus the integral of 1/9 over 2x minus 1.
Similar to like finding the c and then plugging it back in.
Finding, yeah. Right. So basically, we have to find some unknown constants, and yeah, there is some kind of backtracking here. So I've traded my very complicated integral for hopefully a pair of integrals that I can do more simply. So I know what the integral of 4/9 over x plus 4 is. I would love to do that. So if I 4/9 times 1, or say I'll do the same thing for both. Do I know what the integral of 1 over x plus 4 is? That's a natural log integral. So 4/9 times the natural log of what? Careful. Absolute value of x plus 4. Yeah. And then how about the other one? That one's a little trickier. What is the integral of 1 over 2x minus 1? Right. So basically, if it was 2 over 2x minus 1, that would be like a natural log. But I have half of that. So basically, it's going to be plus 1/2 times 1/9 times the natural log of 2x minus 1 plus c. I didn't budget my space well enough, but hopefully you can see that. So we're at the end of our first one. What questions do you have? I know it's not totally simplified, but I wanted to leave the 1/2 and the 1/9 separate. Where that came from. Go ahead. If you take out the 1/2, is it still n over 2x minus 1? If you take out the 1/2?
Yeah, because you said it's 1/2 times.
Right, so let's just talk about this part. The integral of 1 over 2x minus 1 dx. Do we know what that integral is? What is it? We might do substitution, right? Actually, I got a better idea. Let's go the opposite way. What is the derivative of the natural log of 2x minus 1? 1 over 2x minus 1, is that the whole thing? Times 2, right? So because of the chain rule, I've been going, so now we're looking at this derivative. The derivative of natural log of 2x minus 1 is 2 over 2x minus 1, right? So we have exactly half of that. That's where that half comes from, is the fact that instead of me having a 2 in the numerator, which I would need to really have that, to directly have that antiderivative, I have exactly half that. Did that answer your question? Okay. Anything else? Okay. Let's do a new one. Okay, so brand new example here, but we're going to start it largely the same way, and I'll remind you what that was. Basically, if we were adding fractions together, we have to find a least common denominator. Now what we have is, basically, I'm giving you what is a common denominator. So let's think about what the denominators of the simpler fractions might look like to give this. So what might those denominators be? right? So it is these factors, right? So this equals hopefully some constant over 2x plus 1 plus some constant over x minus 1. So are we okay with that starting place, first of all? Okay. Do you remember what we did next? What's that? Right. I'm going to multiply the whole thing by 2x plus 1 times x minus 1. If I do that, what will happen to the left-hand side of the equal sign? 5x plus 1. What will happen to this a term? A times x minus 1 plus b times 2x plus 1. Okay. Can I show you something that's probably a little more efficient than the system of equations way? So what I would love to do is, so I have to solve for a and b, right? I would really like to solve for one of these at a time. So here's what I'm going to think about. First of all, how many variables are in that equation? I got to vote for 3. What is a variable? What's that?
So is it just x?
Yeah, x is the only variable in there. So we have a lot of unknowns, but here's the good news. X is the only one that can actually change, which means if I figure out what a and b are, then I have figured out what a and b are for all situations. So here's what I'm allowed to do. I'm going to choose an x value that makes this equation simpler for me. Can I choose an x value that will either make a or b disappear? If I do x equals 1, I think that's a good choice. If x equals 1, then what does the left-hand side of the equal sign become? Actually, I'll just do it out in detail. 5 times 1 plus 1 equals a times 0 plus b times 3. So what does that give us? That gives us that 6 equals 3b or b equals 2. So this is something you always have at your disposal. You can kind of choose strategic values of x that make these solutions easier to get a hold of. Can I do that again? What's another good value of x to help me? -1/2. If I do -1/2, I have 5 times -1/2 plus 1 equals a times 1/2. No. Yeah. Right. Plus b times 0. Would it be -3/2? Oh, you're getting to the end. Okay, sorry. Here, let me catch up to you. So this would be -5/2 plus 1 is -3/2 equals 1/2 a, which means a equals -3. Wait, why do I have a negative there? So 5 times -1/2 plus 1, that's going to be -5/2 plus 1 is -3/2, right? Oh, yeah, you're right. Thank you. So the -3/2 goes here, which makes a even simpler, right? All right. Am I good now? Okay. So we found a and b. What do we do with those now? So remember, our overall goal was not to split this fraction up. That is a goal, but it's not the end goal. So what do we have to do with those now? Plug those back in. So basically now this integral, I traded this integral that I probably can't do directly for this one, or for these two, 1 over 2x plus 1 dx plus the integral of 2 over x minus 1 dx. What is the integral of 1 over 2x plus 1 dx? So yeah, 1/2 natural log. Where did the 1/2 come from? Right. So basically, whenever you have a derivative, basically, if you ever have like a fraction where the numerator is the derivative of the denominator, that's going to give you a natural log. In this case, we don't quite have that, but we do have a constant multiple. So something you might do here is, am I allowed to rewrite this as 2 over 2x plus 1? But to balance that, I put a 1/2 on the outside. Is that okay? So lots of different ways to think about it, but that whatever way you get to that coefficient of 1/2 is fine. What about the integral of the right-hand function, 2 over x minus 1? Now here we have exactly double of the natural log of x minus 1 plus a constant. Questions?
So you could do either of those processes to find either the substitution
or yeah. I mean, it's totally whatever makes sense to you. Here's what I suspect. Sometimes you'll have more than 2 things, 2 unknown constants to solve for. Solving a system of 2 equations is a little bit hard. 3 equations is much, much harder. So if you can kind of cheat your way around to solve for one of those constants or more, it'll save you some time. All right. Actually, I should just stop here. Any questions on what we did here? Okay. So how do we start this? What's that? Okay, so basically we want to know how this might decompose. So if our common denominator is x plus 1 squared, what might be the denominators that led to that common denominator? X squared, 2x, and 1. Here's the, let's look at that. So a over x squared plus b over 2x plus c over 1. So c plus c. What is the common denominator of x squared, 2x, and 1? I don't think it's x plus 1 squared. But what would it be? 2x squared. So here's the tricky thing. Common denominators are all about multiplication. It's basically least common denominator is equivalent to us finding the least common multiple. I don't think x plus 1 squared is a multiple of x squared, 2x, and 1. So let's try again. And this one's tricky because basically what I have is, what are the factors of this denominator? So I have x plus 1 squared. What are the factors of that denominator? How many are there? 2. What are they? They're both x plus 1, right? So here's kind of a special case, and we call this the repeated factor case. So in the last 2 examples we did, very quickly you all shouted out like what the factors were going to be because they were distinct. In this one we had 2 factors and they're different. In this one we had 2 factors and they're different. This one we have 2 factors and they're the same. So One of our common denominators could be this x plus 1, but there also might be things you added to this that were already squared. What's the least common denominator of x plus 1 and x plus 1 squared? X plus 1 squared, right? So x plus 1 is a factor of x plus 1 squared, right? So I want to make sure we have a handle on why I'm breaking down the fractions in this way. Can I give you an example that's... What if I asked you to add 2/3 and 1/9? Is the common denominator 27? It's not the least common denominator, but it is a common denominator, right? But what really is the least common denominator here? It's 9, right? So these are just numeric. This is algebraic, but it's the same kind of reasoning. This denominator 9 has basically it has factors of a factor of 3. So I can simply use it as the common denominator. But what happens if I actually add these together? I'm going to get, what, 6/9 plus 1, so 7/9. If we were going the opposite way, 7/9 could have been added together with things that were, something with a denominator of 3 and a denominator of 9. So we might find out that that's not the case, but that's kind of that's what we're trying to find out. Any questions so far? Are we ready to figure out what A and B are? Okay, so how can I figure out, where should I go next here? Right, so some point early in the process, I encourage you to clear the fractions out just to basically unclutter what you're trying to do. So what does the left-hand side become if I multiply by x plus 1 squared? 2x plus 3. What's the A term become? A times x plus 1. It's not squared. And this is the thing I wanted to point out, is that here's the thing that a lot of you, especially in my experience, a lot of you are probably seeing like, okay, well, when I clear the fractions, then what happens is basically the A gets the opposite denominator, right? And B gets basically they trade denominators. And that is really a coincidence that comes from you multiplying through by all the denominators. Really, the reason that, from this step to this one, A ends up getting attached to x minus 1 is because the 2x plus 1 canceled out. And similar is true for the B. So the crisscrossing thing is not something that happens all the time. It's all about what cancels. So if I multiply this A over x plus 1 by x plus 1 squared, then I cancel out one of my x plus 1 factors, but only one of them. So I have A times x plus 1. What happens to the B term? It's B, because x plus 1 squared cancels the full denominator. So be wary of that urge to, kind of do the crisscross trade denominators thing. That won't always happen. Are we okay with where we are? All right, I need to find A and B. Suggestions? X equal -1. Okay. So we're doing the strategic values of X. If I get X equals -1, then what's the left-hand side equal? 1 equals B. So that was easy enough, assuming I'm right. All right, so we got one of our constants. Can we do that again? So I don't know if we can do it again, because we don't really have, there's no variables multiplied by b to make it go away, but what I can do is this. I really can make it go away because it's no longer unknown to me. So any suggestions on how to find out what a is? What's your first impulse tell you? We'll just go with that. Go ahead. Okay, so we took one to the other side. Did that help? Yeah, I think it helped. But now what? Go ahead. Simplify it into what? Oh, if I factor that, oh, I was not thinking that, but I think that helps a lot. Does that make it clear what a is? A has to be 2. So I have my a and b, which means I can now think about my integrals in a totally different way. So now I'm doing the integral of what? 2 over x plus 1 dx plus the integral of what? 1 over x plus 1 squared dx. I think we just had 2 over x plus 1. What was that integral? What's the integral of 1 over x plus 1?
That's just 2 ln x plus 1, right?
Yeah, it is.
Yeah.
Absolute value, but yes. Yeah. So that one's handled. How about 1 over x plus 1 squared? That one's a little trickier. How can we handle that? Maybe I should make a little scratch work over here.
Can you do U sub?
I can do u sub. What's a good u? X plus 1. If u equals x plus 1, then what is du? Dx. So this becomes 1 over u squared times du, right? If dx and du are equivalent, what's that integral? Yeah. To make it clear, I will rewrite that like that, and that becomes, go ahead, Pia. Negative u to the negative 1. Or negative x plus 1 to the negative 1. Or minus 1 over x plus 1 plus c. So questions here. I really want to focus on like the special case of this now. So we had a repeated factor in this case. So basically, we had our denominator we started with had 2 factors. They happen to be the exact same factor. So because of that, and just to generalize this, we had a over x plus 1, b over x plus 1 squared. One thing I want to point out is this, is that what if this was not squared? What if this was to the 6th power? Then how would we have to break that down? Like how many of these a plus b style terms would there be? There'd be 6, right? I have to represent every power on the way up. Purely hypothetical, I'm not asking for that. Then c over x plus 1 cubed plus d over x plus 1 to the 4th. So on. So you have to find 6 constants. Not asking for it, but that's one thing that I'm not saying I won't give you more than 2, but 6 is a little much. But just know that basically if you have repeated factors, I need to account for every power ascending up to what the power actually is. Question?
I don't know if you've already
But like my initial thought would be to do like x plus 1 times x plus 1. Is that the repeated factor? Like, so I think
Yeah.
A over
So yeah, you could rewrite. So are you saying to rewrite this denominator as
just x plus 1 times x plus 1.
right?
And then like, why can't we do that?
So here's why you can't, and I think it'll be easier to explain now that we've got to the end. So what if we rewrote this and did a over x plus 1 plus b over x plus 1? Is that what you're suggesting?
Yeah. Is it because like A and B can't?
So then that, if I have this, then, so if I were to add a over x plus 1 plus b over x plus 1, what's their common denominator? It's just x plus 1. They already have the same denominator. So if I start from that place, there's no way for me to get to this thing we have.
Okay.
Another way to prove that is this. We actually found it was 2 over x plus 1 plus 1 over x plus 1 squared, right? Which means there's no way to get to this original fraction without having that squared x plus 1. So sometimes you'll find out that some of these, like sometimes you'll find out that the constants are equal to 0, but you can't assume that going forward. So yeah, that's why having the x plus 1, having both those being x plus 1, because we're not looking at all the places we need to look. Good question. What else? Okay. What's going on here? Oh, that one offended a lot of you. So how do we start? Go ahead. Start by grouping some.
So like x cubed minus 2x.
You could do that. So yes, you could. Let's hold that thought. One thing I want to point out is you knew the factors going into all these, the first three, right? Yeah, so I think that's the first thing we should do is figure out what the factors are. This is the first example I'm giving you where you can't obviously just look at it and see, oh, the factors are this, because it's not factored. So can we factor the denominator? How so?
Like with 4 and
1. 4 and 1. Oh, I see what you're saying. Okay, yeah. So x plus 1, x plus 4?
Would it have to be x?
It would be. I believe that's correct. If we foiled that out, we would get back to where we started. So that's the first thing I'm going to do is I'm going to rewrite this as x cubed minus 2x squared plus x plus 1 over these two factors, x squared plus 1, x squared plus 4. Can I factor it any further? To what?
X squared plus 1 times x plus 2.
X plus 2?
Yeah.
So you're factoring x squared plus 4 into x plus 2?
Yeah.
Or is there another factor?
Yeah.
I don't think either one of these factors. I know what you're thinking of. I believe that x squared minus 4 factors, but I don't believe x squared plus 4 does. So that's something to keep track of, is that, yeah, difference of squares is something you can factor. Sum of squares won't. So I think as far as factoring goes, this is as well as we're going to do. I'm probably going to have to pause this one in the middle, but we'll keep going. So basically, I know what my factors are going to be, but there's one thing we have to pay attention to. This is going to split up into two fractions, one with a denominator of x squared plus 1, and one with a denominator of x squared plus 4. So there's one assumption we've made that we haven't really talked about, but now we should go back and revisit. Do you know the word degree? Like what the degree of a polynomial is? What does that mean? The highest power on the variable, right? What's the degree of the denominator here? Or both my denominators? 2. What has it been ever for every other example we've looked at? They've all been 1, right? I mean, in this one they haven't really been, but x plus 1 squared has a degree of 2. But now our degree is 2, right? So something we've done, we've always had constants in the numerator, because basically one of the assumptions we're making is this: the degree of the numerator is going to be less than the degree of the denominator. So if the degree of the degree of the denominator for all these has been 1, right? So what's the only degree it could have if it's less than 1? 0, which degree of 0 means there are no variables, all you have is constants. These have degree 2, right? So what's the largest the degree of the numerator could be? 1. If we're just saying it's less, we're not saying by how much less it is, just that it's less. Which means these numerators have to have a degree of 1. If that's true, then what do they look like? AX plus B. So if it has a degree of 1, then it could have a linear X term, and it could have a constant. Correct? Because for the same reason, if I told you you had a straight, basically, this is a linear, right? Degree 1. Is this a good equation for a straight line? 2x minus 5. Right, I have to, so every single unknown I have to call by a different name. But a line is a first degree polynomial, right? It could have, well, if it's first degree, it better have an X term. It might have a constant term, it might not. But like y equals 2x minus 5 is a first degree polynomial, so is y equals 2x. But here's the thing, I don't know that it's not going to have a constant, so I have to allow for it. So so we recently talked about the repeated root kind of special case. This is a higher degree factor. So that's why if my denominators are degree 2, then I have to allow my numerators to be degree 1. Are we okay with that, first of all? Question?
In the numerator, why do you have to put one of the constants without an X?
So here's the thing. Let's look at something much higher degree. Let's say I had a 5th degree polynomial. If I'm saying a polynomial is 5th degree, then what might it look like? Like what does it have to have? What might it have? What's that? It has to have something. We'll just say x to the 5th. What else might it have? I don't know what the coefficient is. We'll call it x to the 4th. What else? And on the way down, right? But it also might have a term that has no variables at all attached to it, right? So I did this much higher order example to kind of point something out. If I say a polynomial has degree of whatever, again, what does the degree of a polynomial mean? The highest power of x, right? Not the only. So I know that a 5th degree polynomial has an x to the 5 term, but it might have all the other powers all the way down to 0. So because I can't be certain about which ones exist and which ones don't, I have to allow for the fact that, all right, there has to be an X term in these first degree numerators, but there also might be terms that have a power of X to the 0. So this is X to the 1, X to the 0, X to the 1, X to the 0. I think for this specific example, when we get through it, we'll find out that at least one of those constants is 0, but we can't assume that it doesn't exist. We have to find out for sure that it doesn't exist.
And it can't be squared because it has to be less than.
Has to be strict. The degree has to be strictly less. So one other thing I want to point out with the time, or we're out of time, but real quickly, what's the degree of this denominator? How about this numerator? So all the examples we've talked about so far, what's the degree of this denominator and the numerator? All the things we've started with so far have had the degree of the denominator being strictly bigger. But one thing we're going to get to next time is like this one here. What's the degree of the denominator and the numerator? We're going to have to do something before we even get into the fraction part of it. So that's, I don't want to get into too much more detail, but we'll pick this example up next time.
That second one, you split it into two different ones, right? Like when it was x squared minus 4 on the bottom.
You have to factor it first, yeah.
For the x plus 1 squared,